So the internet of less useless things is what we're going to talk about. So come on in, dudes. There are seats here. Don't worry about it. So the internet of less useless things is kind of my take on what we can do to improve the current state of affairs for IoT devices that honestly suck. But because that you people are going to be able to join me in this, I need to help you understand a little bit more about IoT products. So I have designed a small quiz for you. So can everybody do this? It's very good. That is your left answer. Very good, thank you. So I'm going to show you a set of pictures and tell you a story about each picture. If you believe that the picture I'm showing you is a product that is in production or at least funded to be in production, please raise your hand. Okay? Let's try one. This is FernGrow, a smart wine bottle that helps you detect if your wine is a counterfeit wine or an actual, genuine, old, aged, lovely red wine. How many people believe that this product is in production? Please raise your hand. All right, about 30%. Let's try another one. This is Pura. Pura is a cat hydrator. Pura measures how much water your cat drinks during a day to make sure that your cat is at all time optimally hydrated. How many people believe that this is a genuine product that is funded or in production? About 100%, all right? So, this is the Beat Tweeter. The Beat Tweeter is a ring that goes around your finger and measures your pulse. Should your heart stop, it will send a hearty farewell to all your Twitter followers. Dear beloved Twitter followers, it has been an enjoyment to contact and talk to you over the years. Sadly, I have passed away. Good night. Something like that, right? How many people believe that this is a product that is in production, has been funded? It's about 20%, all right? And last but not least, this is the smart water bottle. The smart water bottle is a see-through plastic bottle with a Bluetooth connectivity and an app that can tell you how much water is in your see-through plastic bottle. So your see-through, also it's Bluetooth, so it's not usable for more than 15 feet. So how many people believe that this is a funded product? About 80%, very good. To be fair, though, they actually also track statistics of how much water you're approximately drinking, so they can tell you to drink more. Everything but the ring is actual products that people have sold and bought. But the problem is that they are not useless things. They're not useless because you're going to buy them and you're going to put them in a cupboard somewhere and you're never going to use them. But they had a use. They made the person who built them a lot of money. Like all of these had fundings of over $150,000. And then people bought them. Right? So it's not useless stuff. What we're going to talk about today is things that really makes no sense. Like when you're building things, you're building broken things. We're going to talk a little bit about how we can build less broken things. All right? So I have an issue. So I've been in the electronic industry for over almost 20 years. And in the electronic industry, there's so much cool projects. Like you come into a meeting room and they're like, we're going to build a mecha robot that's going to attack Japan. Like, whoa. And then they're like, that's going to be so much fun. And then they're like, but before we start this project, you should talk to our lawyer. And their lawyer goes like, yeah, please sign these papers. And it's like 1,000 documents. Like, so if you ever talk about this, we will take your firstborn child and your liver. So that means that, by the way, we did not build a mecha robot. We did build other cool things. So I can't talk about it. So for the next 50 minutes, I'm just going to be quiet. Is that okay with you? Oh, okay. So I'm actually going to talk about home automation. But I'm going to use knowledge that I've learned over the years in my project. So when I'm talking about home automation, most of this knowledge comes from non-disclosure argument class projects. But we're talking about home automation, okay? Okay, because that way I don't get sued. Which is a good thing, if you're me. Anyhow, in 2015, I bought a house. I was so excited. I'm going to do so much cool things with my house. I'm going to automate everything. Everything is going to be analyzed and awesome. When the mail comes, I'm going to know by the second. I'm going to have a push notification. I'm going to have everything. But unfortunately, I have one of those things that comes often with a house. A wife. Which thought that we had other things that we were supposed to do in our house, like renovate and mow the lawn. Boring people. So after a while, I decided, okay, I don't have time to custom build all these things. I need to do something else. I need to pre-buy stuff, at least at work, so I can just configure them and have some sort of functionality. So I bought a small box of hardware that I wanted to use. At least this is how my wife describes it. And I unpacked it, and I found so many things, and I got disgusted, and then I wrote this talk. So let me start criticizing things by starting with the router. How many people have a router in their homes? I'd be surprised if you didn't. So my ideal router is this. It is something that is anonymous, sits in the roof, works well, right? When I started shopping around for routers, like everybody tried to offer me something that looked like this. I mean, I don't even know what this is. Is it a table? I mean, this is not practical. Does router go in heat? Is it trying to attract other routers to mate with them? And it gets even worse, because when you start analyzing it, you realize that the antennas are even, like, they're not even as good as this one. So it has like 16 antennas, less range, and it's just, I don't even know what it is. Like, why did they build it like that? I've seen more than one person on the internet who flipped it around and used it as an actual table. It's nuts. And so many of our IoT things follow the same pattern. Like, they're flamboyant. It's like they're designing the new lead singer for Queens. For Queen, I mean, not Queens. It's like, oh, why are we doing this? Things are supposed to be anonymous. Like, if we can't get it into our house, how the hell are you going to get people to buy it? If your product hangs on a shelf, when you build your product, and then people goes into your store and, yeah, I'd like this function, but my husband or my wife would never let me have this in the house because they are, you know, not geeks. That's an issue. So we need to fix that somehow. So we need a way to measure user acceptance, right? So we're geeks. All of us, we're geeks. You're a geek, I'm a geek, you're probably a geek, you look geeky, sorry. And I mean, that's an issue for us, right? Because we think that functions are cool. We think that functions are good. And most people think that things that look good, which is, you know, not us, which is why people actually can sell the Alexa. So one of the best ways to measure user acceptance I have found, instead of study groups and all of these things, is the WAF, the wife approval factor. It hands down beats out anything from A/B testing to user group interactions to focus groups and all these sort of things. But we have a lot of female developers, so the WAF is not really a good description anymore. So either you can use the SAF, the spouse acceptance factor, or my personal favorite, the MIF, the marriage interference factor. How likely is this product to get you divorced? So, basically what we're talking about here is what can we get away with? How much stuff can we put in our house, or how much functions can we put in our house before somebody's starting to object to what we're doing? Okay? So I have a little quiz for you again. So please raise your hand if you think that putting anything in the following images in your house is likely to get you divorced. All right? You understand the question? Let's try an easy one. Does this image have a high interference factor? I would agree with you. But it's not really enough to get divorced because this is my workspace. This one then. Come on. Does this have a high marriage interference factor? That's good. When I was in rock club, most people raised their hand. And it's like, how picky are your husbands and wives? This one? You are what's faulting this test, young lady. Are you a gamer? Yeah, exactly. This does not work on gamers. If you have a gaming spouse, that just ruins the test. Does not work on gamers. Last one. Does this have a high marriage interference factor? All right, so we have some Apple-hating spouses, but apart from that, I'd say no. All right. So the thing is that I find more and more uses for my spouse in my everyday work. I've been to a very famous refrigerator company. They make more than refrigerators, but especially refrigerators. And we had this great meeting. And they were like, we're going to build a new smart refrigerator. We had this great idea. We're going to use, what's that? Oh, sorry, some radio disturbance. So we're going to build this new cool refrigerator. It's like, okay, what is it going to do? It is going to measure. Come on in, the seats over here and the seats in the front. Anyhow, they're going to build this new cool refrigerator and tell us, we're going to put a barcode reader. So you can scan your milk, you can scan your cheese, anything you put in your refrigerator, and then you put it on a scale that sits, a micro scale that sits in every shelf, and it will keep track exactly of how much of everything you have left in your refrigerator, like milk, like cheese, like all these sort of things. So when you go shopping, you can just pick up your app, and it will tell you exactly what you need to buy. Sounds good. I thought it was a really cool idea. So I went in and I talked to my wife and I told her about this problem. How can we do this? What can we do with this sort of thing? And she just looked at me, shook her head like only she can do, walked over to the fridge and opened it. Yeah, that sounds like a really good idea. And she said, a fridge is a stackable storage space. You put things on top of each other. During Christmas, you need to lubricate things to get things into my refrigerator, right? I bet you guys have the same thing. So this is what I'm saying is that if you're building IoT devices, instead of asking expert groups, use your family, abuse your family, like make them try your stuff. Because they are also having the benefit that they don't have it as a job, and they enjoy being mean to you, right? This goes double for little brothers. But all right, so enough about design and user testing. So we have our router. And now we need functions. So one of the first functions that I built for my house was a power meter. So I had a real-time notification of how much power I was consuming. And because I bought a product for this, this came with an app, a cloud service, all sorts of things. Great. But after a while, I started being like, okay, so I had this for about 6 months now, and I want to predict how much I will consume in the future. All right? So people went and said, okay, how much will I consume? So I need the data. So I sent an email to the company. It's like, hi, I would like an API so I can get my data back. Or at least, could you please export it to, an Excel file or something that I can use in Power BI? And they said, no. It's like, say, it's my data. No, it's our data. What? But don't worry, you can have our wonderful report. All right, so in the next slide, I have included their wonderful report. This is the actual report. There are no labeled graphs. It is for 24 hours. I wanted 1 year. And it was a JPEG. Thank you. So if we're going to build IoT products, we really need to focus on treating our customers right. Like, we need to give them and other system access to our data. Like, if we're actually building something that we want to call IoT, locking their data into us is going to make people stop using our products because it doesn't actually go with the system, right? You get what I'm meaning? If we can interact our robotic dog to the mailbox system so that the robotic dog can go and fetch the mail, we're gonna get another mailbox system, right? Because that's what we got a robotic dog for. Not because it's cute. You with me? Awesome. So we need to respect the users. We need to give them the correct tools. We need to do stuff like this. Because without data, we have nothing. Without data, they have no product, they have nothing to work with. And there actually is a couple of people who does this wrong. So let's talk a little bit more about data. Could anybody tell me what is the similarity between one of the world's largest data collectors, the NSA, and the sex toy WeVibe? Any guesses?
Users don't know about storing their data.
It's very good. Users have no idea that they're tracking data. So it was quite recently discovered that, by the way, if you look around you right now and you see people taking up their phones and uninstalling apps, they own a WeVibe. So, it was very recently discovered, or not recently, but about a year ago, we discovered that the WeVibe, because we were actually involved in trying to sue them, where somebody asked us to do some data research to see if they could sue them. So what does the WeVibe log? It logs your preferred user setting. Like, what setting are you most often using it at, maximum or minimum? It logs how long time you're using it. It logs how often you're using it, like frequent, and how stuff like that. Are you having 30-second install, or are you doing it for 1 hour? And it logs where you're using it. Yeah, and some versions of the app, though, not all versions of the app stores where you're using it. And I'm not talking about, like where, but I'm talking about, in Warsaw or Wrocław, stuff like that. Didn't work out so well for them, but luckily for them, people don't like to talk about the fact that they own stimulants. So they didn't get so much backlash. But it still doesn't mean that you don't have to be open and honest. If you're going to log data, tell your users. Because the users are even going to dream up that if you're a big supplier, people are going to dream up that you're storing data. If you're a successful product, and they notice that even this tiniest sliver of data goes to a server that you haven't told them about, they're going to hate you. And you have never seen shit like a Twitter storm. How many people remember when Windows 10 was launched? Right? Yeah. And there was some data going. And everybody on Twitter was like, they're spying on us! And somebody from Microsoft went out, well, actually, you clicked the I accept button for helping us supplying data? That's that data that is also anonymized in your computer before it's sent to us? So what's the problem? You're spying on us! And people will do that. People will do that. So if you're going to build an IT product and you're going to store data, which is probably something you're going to need to do because you want to supply products, you want to supply data, machine learning, stuff like that, but do tell people about it, and tell people about it openly. Not a footprint. Big. Tell people about it. Because the users must trust you. Without trust, you have nothing. Let me give you an example. So how many people remember the Revolve? This was many years ago, before Nest. Google bought them. They were bought by Google. So they were supposed to do similar things that the Nest did. But didn't really work as well as Nest did. So Google bought Nest instead, and this product was cancelled. But it wasn't cancelled in a nice way, because people bought the hardware, people installed the hardware in their homes, then they shut it down. They turned off the servers, and everything stopped working. So people were stuck with $300 worth of hardware with no function. That's not a good thing. The narrative clip 2 faced similar things. They were not selling well enough, so they could not afford to keep their systems running, or this product was not a success. So what the narrative did instead of shutting down their servers and just giving up was that they said, okay, hey, you know what? We're going to push the last update for the app So it supports offline usage, so you don't need our service. You can store it to your phone and then sync it to your computer. Also, since we're not going to run it anymore, we're going to release the servers open source, so you can host it yourself if you'd like to, and then you can configure your service and all that sort of thing. They had almost no backlash on social media because everybody understood, okay, it's fine, you can bankrupt. You can fail. That is part of this industry. We were early adopters, we understand that, and you have went out of your way to make sure that we can still use the product we paid for. Now, I would not buy a Revolve product anytime soon, but if Narrative would come out with a new system that works better, that I would like, yes, I'm happy to buy it. You get what I'm saying? This is a very important thing. I mean, this is like selling a mobile phone and then asking people to pay money to build apps for it, right? Who would do that? So what we're trying to say really is, don't piss on your customers. They're the reason you have a job. All right. So, after I had a brief encounter with the electronical logger of how much consumption I had in my house and the trash bin, I decided that, okay, now I want to start automating things. Like I want notifications when my dishwasher is done. I want all sorts of stuff, which is basically why I wanted the predictions in the first place. So automation can be quite tricky, especially for selecting the right device, as Samsung may have noticed over the last few years. A lot of times when I talk about IoT, people come up to me and say like, sorry, my throat is a bit... anyway, they come up to me and say like, what is the best hardware platform? Like, we're going to build a product. Like, what are we going to use? Should we go with something custom built? Should we go with Arduino? Should we go with something smaller, cheaper, more expensive, better, JavaScript, C, assembly, throwing ones and zeros into a terminal? What should we do? And I understand that this is an issue, but I really wish it wasn't. How many JavaScript developers do we have in this room? How many .NET developers? All right. So how many STM32 assembly developers do we have? 1. Very good. So the thing is, though, that we have a massive amount of C# developers. We have a massive amount of JavaScript developers. We have very, very, very few assembly developers for STM32 and actual production-ready processors. So instead of, when we're building prototypes and stuff like that, which is 95% of all projects because a lot of projects are being scrapped, we need to understand that IoT is not a project in itself. We're not building IoT to build IoT. We're building IoT to solve a business problem, right? If we're putting sensors in an elevator, we're not doing it to make a smart elevator. I mean, we geeks are, because it's fun. But I mean, the actual reason people pay us to do this is because they want to know, when should we service this elevator? Has the elevator fallen down? Stuff like this, right? Is the elevator degrading over time? Like, what data can we use from this elevator? That's the reasons why we put sensor in it. We're solving a business problem. So if we're solving a business problem, that means that to just test if this works, if we just want to throw something out there, and you can find a microprocessor that talks JavaScript just to test your problem, well, go for it. You're going to be much, much faster to market. There's Raspberry Pis and Windows 10 IoT Core that does C# right out of the box. You can deploy a UVP app to it and log data. All the things we know about. And then, when you actually have a product, that's when you call in the STM32 assembly developer guy. Stands in the back, by the way, take his number. I mean, or give me more job, that's also possible. So, but I mean, before you actually have a product to work with, there's no point in selecting a hardware platform. Pick whatever gives you the fastest movement. Whatever can help you move the fastest. That's the thing you're going to choose. Right? That makes sense to everybody? Cool. Success. Because when you actually have a success, that's what I'm saying, that's when you bring in the hardware designers, the people who knows about electronics. Let me give you an example why you should do that. So how many people have a phone with a battery that dies often. So I have an iPhone, which means that I have about 25 minutes of battery power every day. Sadly. How many people have an iPhone? Yeah, feel sorry for us. So the problem with battery power for most devices, and let me show you a little example. So we're going to talk a little bit about this. So if you have an Arduino, a very, very common thing, and you put a 9-volt battery to it, to a regular Arduino Uno, it's going to last for less than a day, less than 24 hours. So if you build a device based on the Arduino, it's going to last in less than 1 day. If you take a smaller Arduino, like an Arduino Pro Mini, which is a much smaller device than the Arduino Uno, it's going to last for roughly 10 days. That's the maximum. So what we're doing here is connecting ourselves to a transmitter, sending a signal, blinking a LED as we get the confirmation, and then that's it. That's what we're doing. So there's not even a lot of work going on inside the processor. But if you take an Arduino Pro Mini, you remove the power LED, you change it to a better regulator, and you write code a little bit more smartly, like if you actually know hardware development. So I have one that's been running now for 3.2 years. I have calculated it should last for at least 3.6 years before we have to change the 9-volt battery. So we went from 10 days to 3.6 years just because we know what we're doing. But for a prototype, you don't have to do that. You can easily change the battery or run on a much, much larger battery. Like, okay, here's my prototype. It comes with a car battery. We'll solve it later in production. I'm not even joking. Why not? If you're just going to put it on top of an elevator or whatever you're going to do with it, doesn't matter. As long as it solves the problem, we can do some tests, right? So how many people knows about interrupts? So say, you have to raise your hand. You said you're an STM32 assembly programmer. I'm going to keep watch on you, dude. Ah, right, he never said he was good, but it's kind of an intricate thing, you know. So knowing about interrupts for microcontrollers is you have to do that if you want to save battery power. So one of the things that we started doing with these devices is we put them in sleep mode. So they wake up, they connect to the internet, they send their signal, they receive the data, then they sleep for 60 seconds. They draw almost no power for these 60 seconds that they sleep. All the other devices drain almost as much power when they're online. So we haven't actually modified the code, but we modified the runtime of the system. And that's something that you don't have to think about that much when you're doing prototypes. But it's also one of the reasons why you need hardware developers that know their stuff. Another thing that we changed was that we went from HTTP connections. So HTTP connections into MQTT connections, which is telemetrics. So AMQP, STOMP, and MQTT are all pub-sub patterns. They're small binary compiled data transmitting protocols. I used to actually describe them for customers like this. They call the mustache guide. So the AMQP is a big and beautiful de France mustache. The MQTT is the small Spanish one. I can't do a Spanish accent, so assume. And the STOMP is more of an American sheriff mustache. You know what I'm talking about? You know, ready for action. And HTTP is more your granddad. So HTTP is almost 10 times larger when it comes to how much data it must send, which means that we have, on a bad connection, we have a much, much, much longer time before we have any sort of possibility to go into the sleep mode. Are you falling asleep, sir? All right. So the smaller protocol, the less power we're going to need, right? And one of the things that we could have done, which we didn't, was that we did not go from Wi-Fi to radio protocols. Like if we select radio stuff, it's going to have a lot less overlay than the TCP protocol and the Wi-Fi system has as well, which means that we can additionally cut down stuff like this. Also, when we're not prototyping anymore and we're going back to what I talked about earlier, smaller, cheaper micro platforms, then we might not even be able to build HTTP protocols because we need handling text and stuff like that, they're so much better at binary values and so much faster at binary values. Cool. I'm going to come back to this a little bit more from another point of view, so keep this in mind, please. The next thing that's really important if you're building IoT devices, which almost no IoT person is doing right now, is design with failure in mind, like these guys. You have to assume that your device can fail. Like any normal home automation connection is built something like this. It's a button connected to a microprocessor that sends a signal to another microprocessor that tells it to turn on the lamp. You see all seen this, right? Like Nexa does, and all sorts of systems. This is a very good way to do it if you like to look for errors in the dark. So if you have a night vision goggle you really want to test, this is a very good way to design things. But if you're not a Russian prepper, you might not want to build it that way. So one of the first things you can do when you're designing stuff like this, no matter if you're designing machine control system or lamp control systems, it all goes back to the same thing, is to actually let the button directly control the microprocessor and let the microprocessor control the lamp. Now we remove one fail path, just like when we're writing code, right? This is something that cannot fail because it doesn't have to have a wireless transmission. All the thing we need is a cable connector. But that means that the software has to work to actually turn on the lamp. So what we can do instead is actually let the button control the lamp and then let the button also give a state to the microprocessor that tells the lamp is on. Suddenly, the entire hardware can break down. We can still control the button using the microprocessor to change the state of that and turn on the lamp, which means that we can always look for a problem in light, which is quite nice. And we can even add sensors to make sure, is the lamp actually working? Is the machine that we're currently controlling working? So that we can send events like, okay, this lamp is broken. Let's send a technician to this room to go and fix it, if it's less than 2 people in the room. That's perfectly possible if you have that sort of systems in place. But not if the only thing we did was send a signal and then nothing happened. Because we have no idea where it failed. Is the lamp broken? Is the radio transmission broken? Is one of the microprocessors broken? You understand what I'm saying? Cool. So don't do this. Another issue that a lot of IoT developers does is cloud services. So most IoT devices that I bought connect directly to the cloud service of the person. So they need to have built-in Wi-Fi systems. Which makes it very hard for the people to do this to prepare for failure. You never know when that's going to strike. So what happens if the internet connection goes down? All my IoT systems dies. Like, for example, I had a home lock that's connected that was impossible to use if the Wi-Fi was down. That's not a good thing if it starts a fire, my Wi-Fi burns up or my power goes out and, oh yeah, I can't open the door. That's an excellent way to kill your customer base. So how can we solve this? How can we build this a little bit more sustainable? The first thing is to introduce logging. How can we log the data so that when the internet comes back up again, we can at least unlock the door then and let out my carved carcass lies dying in front of the door, right? But what we all especially can do, and what most people should do, is introduce some sort of field gateway. A field gateway is simply a system that don't worry about it. A field gateway is a system that communicates with your microprocessors, allowing your microprocessors to not have to use Wi-Fi, which we talked about earlier, gives us better battery time, and gives us other benefits of this. Also, it makes them much harder to hack, because they don't have to actually have an internet connection. So you have to get into your field gateway, and then you need to get into each separate sensor. So it also makes points from a security standpoint. And of course, if you have a field gateway, you can add more than one connection. You can have Ethernet, you can have Wi-Fi, you can double it up, have 2 field gateways that communicate with them, have them connected to a 4G rollover and stuff like that. So as soon as you basically are here, you're no longer in my domain. As soon as you're in the field gateway is just a computer. Then we're in your domain. And of course, you can back it up to Azure, or AVS, how many cloud providers you feel is necessary to keep everything working, depending on how secure your stuff needs to be. This slide made a lot more sense before I switched to a Mac. Now it's just a slide. Before, people actually believed this. So what would happen if I actually had this issue? Well, I just bring up my second laptop and my presentation on my second laptop and continue. Because I designed this with... Exactly, failure in mind. Very good, sir. You're listening. So, the last kind of design thing I'd like to talk about before we get into really serious stuff is out of sight is out of mind. So I talked a little bit before about how my hatred for ugly routers, right? The table router. If you put something in a roof, people won't see it. Without looking up, how many fire alarms are in this roof? Without looking up.
8.
1, 2, 3, 4, 5. See, I didn't have no idea. I probably should have counted this before. But the thing is that we have no idea because we don't look. We don't look in roofs. Why should we look in roofs? Roofs are roofs. Which means that we can put in a lot clunkier stuff in our roofs and people will not notice them. So things that goes in the roof and is this roughly the same color as most roofs have very, very good or very, very low matters interference factors. Cool? Also, people rarely look under stuff. I could have taped $500 bills underneath each of everyone's share here, and you guys would have no idea. You would just have sat on my $500 bills, and then you would have left, right? That's weird. There's no $500 bills underneath your seats, by the way. But that's the point. People never look underneath stuff. So if you're doing things that needs to have a location, like under a table, can be a very good location because people are never going to look for them. So it's a design aspect of this where you simply place things. And of course, putting things inside a wall can be very tempting, but getting out a sledgehammer to debug it is not. There are perfectly fine boxes that people are very happy to put in their homes regularly for fuse boxes and systems like that. You can just use. But my point is that I like things to be hidden. I don't want to see your things. I'm a bit peeved by the Alexa because I like the Alexa. But the Alexa is designed to be a centerpiece in my home. And I don't want my friends to come home to me and say, like, oh, you got an Alexa. Cool, I should probably get one too. Because my home is not their ad space. So when I'm building IoT products, I'm trying to think about this. Like, how can my products be as anonymous as possible in your homes? And you should think about the same thing, even when you're prototyping things and when you're doing UX for IoT things. You should think about this. Like, how can we do this in a way that people would not hate us for it? Like, our homes are not your ad space. So, we have mentioned user experience, hardware development, field gateways, and a lot of stuff here. So why does this matter to you? Because none of you are IoT developers, right? So why are you in an IoT talk? There's one guy in the back who even knows what STM32 is. Okay, sorry. There's 5 guys in the room who knows what STM32 is. Sorry. But why are you here? Because I know why you're here. But have you thought about it? Because you're here because you're interested in building IoT products, right? I hate you. Most people are probably here because they want to build IoT products. They want to be part of building IoT products. Or at least they have a business problem that they want to solve with building IoT products. And what I'm trying to get across here is very, very easily demonstrated with asking the question, what is the similarity between an IoT expert, Santa Claus, and the Easter Bunny? Any guesses? I'm sorry? It's very good. They do not exist. Because it's like saying you're a full stack expert. How many full stack experts do we have here? None. Because it's not possible. You need to be like an expert on servers, hosting environments, networks, data modeling, business logic, API layers, you're in for UX, business and customer needs. And it's just not possible. And if you're going to be an IoT expert, you have to add like circuit design, MCU programming, machine learning, security, big data, communication protocols, hardware debugging, and so much more, which is impossible. So what I'm trying to get across here is that I'm very good at microprocessors. I've been working almost all my life with microprocessors. But you do not want, well, let me get to that. But my point is that you have a space here. You don't want hardware engineers to write your code. Like when we're talking about a field gateway, what is an actual field gateway? A field gateway is a bridge between a hardware device and an API. As soon as it enters the bridge, anything that comes out from there is going to be probably simple WebSocket calls or REST APIs. And I know a lot of really good hardware developers that knows nothing about building APIs. But what I'm thinking is that most of you guys know a lot about building APIs, because a lot of you people build APIs, right? How many of the .NET guys know Web API? Seriously? 2? How many of the .NET guys in this room knows Web API? Come on. Thank you. And most of them. If we're going to go ask the Node guys, how many of the Node guys can build a REST API? Most of them can, because that's what they do. Right? Just expose things to their web front ends. And let me tell you a little story that happened 5 days ago. So I was in a meeting, and there's a hardware engineer in this room, and we're talking about then we do an API for this data, and we implement Swagger so everybody can just generate their clients, and he's got no, that's not how you do it. That is not how you do it. It's like, okay, how do we do it? So this man is somewhere north of 55. So we are young in his eyes, I think. But no, that's not how you do it. So okay, how do we do it? Well, you see, it's very risky to write your own APIs. It is? No, I think most people do. No, people have stopped doing that a long time ago. Really? Yeah, they use standardized APIs now that you configure with XML. I have not even heard about any doing that since 1999. And it was a bad idea in 1999. And we had an argument if we should use an Apache product that had its last update in 2003 that you configure with XML, which nobody uses anymore because we discovered JSON. That is the reason why most hardware engineers should not write back-end code. Because we end up with that sort of solutions. And we don't want to do that. In fact, when I'm writing code, I want to focus on what I'm good at. But if I have to focus on writing like a front end or using React or something like that, that's going to take most of my time. And it's going to give me less time to focus on building a good product. Likewise, this is what we want to do. I want to spend maximum amount of time on my product, and I want somebody who is awesome at React to come in and build a React site. So what we have to understand is that we're working with the same problems, with the same solutions as you guys do every day. So IoT is not a project. It's not a project type. We're doing an IoT project, like when you're saying you're doing an API project. IoT is a business problem solving tool. Nothing else. It's just hardware that's connected to other hardware. People may dress it up and look as much as possible as it is, but in the end, it's just another way to get data into your system from a lot of interconnected devices. And it can do a lot of really cool things, but not without the entire developer community. Let me show you. Like field gateways, just computers. There's computers with something connected to it that allows you to talk to microprocessors. But apart from that, it's usually a Linux system that you can program with Python, Node, whatever you like, because it has lots of power for it. Java, C# these days, whatever you like. So as soon as you get here, it's computers. Hello, man. Offline support, if you're working with offline support, you guys have done that for years. For us, it's new stuff. Like how many people have not built like offline website support, apps with offline support? You know what data to store, how to work with it, how people work with these sort of things. We don't. We have never done this sort of stuff before. When we're talking about integrating logins, for some hardware developer I met, tokens is a new thing. They're still sending, client-side encrypted passwords. You guys have already worked with federated logins, Facebook, Twitter, LinkedIn, all that sort of stuff. When we talked about the interconnected cloud and building cloud services, you guys have used Azure, Amazon, all of these sort of tools. You understand where I'm coming from? All the architectural patterns, just the same thing. They're equally. Like most times when I come into a hardware design project where they had to write the APIs in the backend software, it looks like something like this. It is devices communicating with a specific set of protocols to a big monolith. And there's nothing wrong with monoliths in some cases, but what happens when you want to add, let's say, an MQTT pattern? Okay, now I want to talk MQTT to this. Is it easy to implement? And they say like, what? No. Everything is hard-coupled. But if we would sit down there, we actually build stuff with this, we would know how to implement, let's say, a consumer and adapter pattern. So that we could just put in adapters in front of our solution and have a specific set of endpoints where we want to go to. And this is not something that I want hardware engineers to learn. This is something I don't want them to have to work with, because there's so much stuff in their line of the world, exactly like it's so much stuff in your part of the tool chain. It's better if we could just all agree that there's not one group of people that has to work with IoT projects. IoT project is one of our tools, and we should solve these problems together. And don't even get me started on continuous integration and continuous deployment, because we have all those tools, but very few people use them. I was in a company that used Git, which is quite uncommon, sadly, for a lot of my clients that work with hardware. How many people use Git? My kind of crowd. Good. So I came into them, and they're like, oh, no, you can't branch. What? Why can I not use branch? Well, you see, we made an underlying library, so you have to check out that library. Then you have to check out all of these Git repos into these specific folders of that Git repo. What? Yeah, it's better that way. I'm gonna have to argue a little bit about this. So they have replaced branching with repos because, well, they've never used source control before. Also, Git doesn't lend itself really, really well to hardware tools and all that sort of thing. But still, it is something where we could have done a lot better with some knowledge. So, let's recap. Always designed for WAF, it will be the better system. What was a better term for WAF? Anyone? MIF, very good. The marriage interference factor. Always strive for a low MIF. Select the device most suitable for the job. If you have 100 JavaScript developer and one hardware guy, let the hardware guy come in when you actually have tried out something that works, because the JavaScript guys are perfectly capable of writing hardware code in JavaScript and just deploying it and testing if something is actually a good idea. The hardware guy can work on actually implementing prototypes as opposed to be products. There are quite a few of them. Keep it hidden but accessible. Don't put things into wall, because debugging with sledgehammers might sound fun, but it isn't. Right? And design with failure in mind. Like, it's very, very important that we keep it clear to ourselves. Like, how are we going to solve our issues? What do we do if this happens? What do we do if that happens? Without keeping that clear to us, we're never going to have a successful product. If it can't be replaced, it will be there forever. So this is a very good thing to think about. Like, if we put something in a wall, you will never get it out. If you have things that you solder to your device. Like, let's say, if you want to upgrade something in your device, like, let's say, the RAM memory in my MacBook. It's not a good thing to solder them to your things. Like think about these sort of things. With most systems, the end goal is scalability and adaptability. That makes sense? Awesome. So what I'm trying to tell you today is that IoT is not just something that we hook up to the internet. It is there to represent something. Like if I hook up a microprocessor to this chair, that's my IoT product. That's my thing. It is a physical representation of this chair. But as soon as this enters a digital space, as soon as I'm representing this chair in a digital space, it is no different than any other class or object that we enter our source code. Just because it has external inputs. Everything has external inputs. If you do machine learning on customer data, the only difference is that you didn't, in real time, access that the customers was going into your store. Apart from that, everything else is the same. You get what I'm saying? So, if you have IoT projects, or if you're in your company see that you have products that could be solved by adding sensors, by adding functionality that you can get from the IoT kind of industry, don't be afraid to lift this, because it will benefit you and it will benefit your career. And never forget, the simplest ideas can become the great products of tomorrow. Or at least make you a lot of money. All right, thanks. My name has been Karl-Henrik Nilsson. You can find me on Twitter if you use it. I run the Dalarna office in Sweden for 1337, so if you ever need a hardware engineer, you know what to call.